Welcome to my channel Mathematical Clinic of Subhash Jha. Friends, if you have not subscribed to my channel, please subscribe it and even press the bell icon so that you can get the information of my newly video uploaded. Today we are doing numericals of limit of algebraic function taking the form infinity by infinity. The last video we discussed about the algebraic function taking the form 0 upon 0. Now talking about the algebraic function taking the form infinity upon infinity. If any algebraic function takes the indeterminate form infinity upon infinity, then to find its limit we divide each term by maximum powered variable involved. For example, if you substitute x equal to infinity here in this question 1, this becomes infinity, this one infinity, this one is 3, so altogether numerator becomes infinity, even denominator becomes infinity, so the function will take the form infinity upon infinity. This one is the purely algebraic function and taking the form infinity upon infinity. So to determine its limit we have to search the maximum powered variable involved here. We are able to see x square is the maximum powered variable involved in this expression 1. So we divide each term here, 1 2 3 4 5 6 terms were involved there. We divide each term by that x square to get the answer 1. Let us do so. First we'll have to write the given function takes the form infinity upon infinity when x equal to infinity. The given function takes the form infinity upon infinity when x equal to infinity. So as I told you, let us divide each term by x square. Limit x tends to infinity as it is. We divide 5x square by x square as well, even 2x by x square, 3 by x square. Do same in the denominator, 4x square divided by x square, 6x divided by x square, and finally 5 divided by x square. Here x square and x square will cancel, 1x and 1x will cancel. Here also same, x square will cancel, 1x and x will be cancelled. Then you are left with limit x tends to infinity in the numerator, 5 plus 2 upon x minus 3 upon x square. In the denominator, 4 plus 6 upon x plus 5 upon x square. Now let us substitute x equal to infinity. The result becomes 5 plus 2 upon infinity is 0, 3 upon infinity square is 0, 4 as it is, 6 upon infinity is 0, 5 upon infinity square is 0. That is why 5 upon 4 is the answer. Only one thing you have to consider, that if it is purely algebraic function and taking the form infinity upon infinity, then you will have to find the maximum powered variable. Here maximum powered variable is x square. You divide each term by that x square, simplify it, finally substitute x equal to infinity and get the answer. Move to second question. Second question is limit x approaches to infinity, this expression 1. Again let us think. First of all, this one is an algebraic function, purely algebraic function. The second thing, if you substitute x equal to infinity here, 2 into infinity becomes infinity, plus 3 is infinity, to the power 6 is again infinity. Infinity, this one infinity 2, infinity into infinity is another infinity. Here this one is also infinity. So finally, if you substitute x equal to infinity, then the value becomes infinity upon infinity. This function also takes the form infinity upon infinity when x equal to infinity. So in similar manner, you search the maximum powered variable, but here the question is different one. Here power 6, here power 10, sorry, here power 4, altogether 6 plus 4 equal to 10, downwards also power 10. So cause they are not same, cause the base of the power are not same. First of all, we break this power 10 into two groups. First part will consist power 6 and second part will consist power 4. For example, we break the denominator like this: 2x plus 3 to the power 6 as it is, 3x minus 5 to the power 4 as it is. This power train should be broken into two parts: 2x plus 1 to the power 6 in the first one, and 2x plus 1 to the power 4 in the second one. 4 plus 6 plus 4 equal to 6 plus 4 equal to 10. We did that because now we are able to write it as here also power 6, here also power 6. So we can write it as 2x plus 3 divided by 2x plus 1 to the power 6. By the same technique, these can be written as 3x minus 5 divided by 2x plus 1 whole to the power 4. Now let us apply that mechanism here inside the bracket. What's the maximum power in this first expression one? It's x. So let us divide limit x tends to infinity as it is. Divide each term by x. If 2x will be divided by x, then it will be 2. If 3 will be divided by x, then it will be 3 upon x. If 2x will be divided by x, then it will be 2. And 1 divided by x will be 1 upon x to the power 6 as it is. Same thing here. Let us divide here also. Maximum powered variable involved is x. So let us divide each term 1, 2, 3, 4 terms by x. It becomes 3 minus 5 upon x. If you divide 3x by x, then 3, 5 by x, then 5 by x, 2x by x, then 2, and 1 by x, then 1 upon x to the power 4. Now let us substitute x equal to infinity. The result becomes 2 plus 3 upon infinity will be 0. By 2 plus 1 upon infinity will be 0 to the power 6. Here 3 minus 5 by infinity will be 0. 4 plus 1 by infinity will be 0 to the power 4. It is 2 upon 2, 1 to the power 6 is 1. Here 3 to the power 4 is 3, 3 is 9, 3 is 27, 3 is 81. Divided by 4 to the power 4 will be 4 4 is 16. 16 4 is 64, 64 4 is 64 into 4 becomes 4 4 is 16, carry 1, 4 6 is 24, 125, 256. So the answer is 81 upon 256. Let us do one more question. The question is, limit and x tends to infinity, n tends to infinity, 1 plus 2 plus 3 up to n divided by n square. If you substitute n equal to infinity here, so last term will be infinity, and infinity plus finite number is infinity. So numerator will be infinity and denominator also infinity whole square is infinity. This one is also purely algebraic function and taking the form infinity upon infinity. So we follow the same process, but rather than dividing its terms by n square here, we'll have to apply some algebraic technique. The algebraic technique one, first of all, make the question purely algebraic in the simplified form. Thereafter apply that technique we have just discussed. We know that the sum of first n natural number is n into n plus 1 divided by 2. This is the formula of sequence and series, and denominator consists of n square. 1 n will be cancelled. This 1 upon 2 will be kept out, and you will be left with limit n tend to infinity, n plus 1 divided by n. This can be written as 1 upon 2 as it is, limit n tend to infinity as it is. Let us separate both the term by n. It will be n upon n equal to 1 plus 1 upon n. Now let us substitute n equal to infinity there. It will be half 1 plus 1 upon infinity is 0. So answer is 1 upon 2.